Madison Zulowitz, and I am the event coordinator here at Doug. So I help run our local and our regional meetup program. Just going to tell you a little bit about Doug and kind of help answer any questions that you may have. Doug is a free community for users, implementers, and resellers of Microsoft business applications. Our main mission is to support the Microsoft Dynamics 365, GP, and Power Platform community. We want to be able to give you the tools and information to excel and grow in your personal and professional careers. Our rules of engagement is that we essentially ask that these meetups are held to be solely educational. So please no sales pitches. We want everybody to be able to come to these meetups and gain some free educational content, but not be sold a product. As for our attendees, we also ask that you ask lots of questions in the chat, engage with your speakers. That's how you get the most out of these meetups. And, the speakers taking some time out of their day to volunteer and share their knowledge. So ask some questions and get as much valuable information as you can. Doug or Dynamics User Group, we offer multiple different programs. We have some open online discussion forums that are free. So if you have a question about a specific product, you can go on there and ask your question and the community will help answer. We also have free virtual webinars. We have some conferences, which I'll get to in a little bit. We have our local meetup program. So we do virtual and in-person local meetups, just like this one. And for the virtual ones, if you aren't able to attend, you can check out our YouTube channel. All of our virtual meetups from around the world are posted there as well. So if there's a specific topic that you're curious about learning about, I'm sure that one of our local meetup groups has probably had a session on it. So YouTube is a great free resource to gain some educational content as well. We have our DynamicsCon regionals. These are a little bit larger in scope than our local meetups like this one. They're usually full day to 2-day events that are held in person. They're free to attend. They usually include some coffee in the morning. They include a lunch and typically a social hour at the end. So really great networking as well, just to get involved in your local community. These are all of our regionals happening in North America, but probably more pertinent to you all is our West and East Africa regionals. So these are coming up very soon. July 19th, we're going to Accra, Ghana. And July 24th and 25th, we will be in Nairobi, Kenya. So this is a great event to attend if you're able to. They're completely free. We provide some lunch. We have a social hour. And again, just a really great way to get involved in your community. So I'm sure a lot of people on the call are already attending or on our leadership team. But we have a great full day of content laid out. So would encourage you to attend, and I'll send the links in the chat after I'm done presenting. We also have our 2026 DynamicsCon coming up. This is our largest conference of the year, and we are going to Las Vegas this year. So we have our early bird pricing going on right now. It is May 12th to the 15th of 2026. This is an almost full week of educational content, definitely a larger scope than our regionals. I think last year we had about 2,000, a little bit over 2,000 attendees come and attend. So if you're able to join us, we would love to see you there. You can scan that QR code for the early bird pricing. And then if anybody has any specific questions, feel free to drop me a chat and I'd be happy to answer. Thanks, everybody.
All right. Thank you, Madison. Over to you, Jeremy.
All righty. Sounds good. Okay, well, hello, everybody. I'm going to get some screen sharing going. If this wasn't clear, we're going to be visiting some content I did for the Tech Days community not too long back. And just because maybe some folks don't know a little bit about who I am, I've been working with BC now for a little over 25 years, development, consultant, trainer. I've written some books about BC. I've been an MVP for several years now, and provide a variety of different free and open source utilities for the community. And so let's jump right into content, because we're going to have some interesting things to cover today. What this talk is about is AL code and how we can make AL code run in good parallel, thinking about performance and locking and all that sort of thing. And because I got
Jeremy,
a lot of... Yes.
Do you want to go to presenter mode, or you're okay with that, sharing that way?
I'm okay with sharing this because we're going to alt tab a lot to
Okay,
some
no
of the
problem.
Visual Studio. Since I got a variety of questions leading up to this content being made available, that, is this about like scheduling job queues and how do job queues work? AJ Kaufman has some sessions about that he's done that talk a little bit more about the mechanics of job queue. And I'm not necessarily going to cover managing job queues today. And because it was very relevant at a conference full of talks at 2 or 3 days of talking about copilots all the time, this one is not copilot oriented. The why this talk, a short little story on this. I joined the company I'm working with at the moment, Brightcom Solutions here in Sweden. We had a customer where we had built an integration to a web shop with transferring orders from the web shop into Business Central. And like a lot of integrations, you need to potentially have those things run on a schedule basis, go fetch orders every few minutes, all that sort of thing. And the way to do that is through job queues. The problem is that this customer was experiencing a volume where they were having 2,000 to 3,000 orders per hour during Black Week last year, a very big sales holiday time of year in Sweden. And they were very concerned because they knew that they were growing and they were worried about the ability of the system to keep up going into the next year. And because of that, they challenged us to come up with better strategies that our job queue would read these web entries from orders coming in, process them into Business Central orders, and those would then go out to a warehouse system. This took a long time. And so they asked us to come up with a different strategy. And we did what I refer to as spaghetti brainstorming. If you take a pot of spaghetti pasta noodles and throw it against the wall, some of them will stick, some of them won't. So we looked into what ideas would stick. And we were trying to address the scenario. And I suspect some of you may have already experienced these problems and challenges, or may encounter them in the years ahead, where you're dealing with a customer that has high transaction volume. There's some data validation operations that need to happen. Our customer, for example, when they were all of these orders were creating customers. So this was a high volume of customer creation and validation. Data operations were creating customers and ship tos and sales orders and sales lines and lots of data operations. There were buffer tables that were getting stuck. And of course, for this customer, that's how they get all their orders. So it's mission critical that this worked for them. And they described it as painfully slow. And that's never a good position for anyone to be in. So our scenario today is that we're going to mimic that with some demo code and demonstrations that we're going to go through a web shop flow where orders are coming into Business Central, maybe some sort of API or whatever have you, and that gets populated into a queue in Business Central to be turned into orders to go out to the third-party logistics and to be emailed. So in that flow, we have to do some validation logic where maybe we're checking just quality of the order coming in from the web shop. We then need to do all of our business logic. Does the customer exist already? Does the ship to exist already? We're going to add a couple extra pieces onto that that we'll talk about. And then theoretically, we would emit those to like a third-party warehouse, and we might need to email those out. So for today, we're just doing a mock connection because it's just a demo, and we're going to mock those emails. So in our baseline sample, what has to happen when an order comes in is it goes into that web queue via an API call from our web shop, calls into Business Central, writes it in there. Our job queue is then going to pick up those queue orders, and it's going to check to see if a customer exists, if a ship to exists. If they don't, it needs to create them. We're going to create a sales order from that information. So a header, a bunch of lines, and then our demonstration scenario, we did a little bit of extra business logic that says if we don't have stock in the main location, but we do have it in one of our other locations, let's also create some transfer orders. And if we have no stock anywhere else, let's create a matching purchase order to be able to hit the demand on that. And then after all that operation is done, we might emit that to a warehouse and send an email that it's either been shipped or it's back ordered waiting to be purchased. I don't want to spend too much time in PowerPoint because we're here for code, right? So the structure of my demo is that we've got our scenario where we have a bunch of customers, some ship-tos existing already, some items existing already, and we're going to have a scenario where a bunch of orders come in and we'll create a bunch of things. Now, to give you a quick little baseline, here I've done what I often do when I'm doing demonstrations of code. This is a custom role center to see all of the elements that are happening as the process is moving. So what we'll be able to do is we'll see that when we're processing things that come in as new web orders, those will move through the different validations to the released orders step, to the third-party logistic fulfillment side of things, and then eventually that it's been sent as an email. We'll keep a count on the number of sales orders and purchase orders and transfer orders that have been created. And if there's any errors processing the information, which the most common error people were expecting me to get is from deadlocking. From when you have multiple jobs running at the same time, they can bump into each other. Tables are locked. So if we get into any of those locking scenarios, it should trip into the error state. Whenever I'm doing demonstrations, one of the things I've also encouraged at past Tech Days talks is build yourself a toolkit that establishes your baseline. This is also a good philosophy if you're doing performance testing and you need to prove to someone that something is working very well. Set up a routine like this where you can just reset your whole application back to your starting point. So this little set of actions up here is going to help me through this demonstration. So we're going to generate some web orders now, and hopefully this will only take a second or so. And there we go. So okay, so now we've got a queue of web orders that have come in from our web shop. And if we take a look, we'll see that here's our little JSON that we would get from a web shop that has, the buyer information. It might have some ship to info, or it might be using the default. We have some item numbers, some quantity, if we're potentially bringing in prices. So this is coming in from the web shop, and these are all waiting on this status new. And nice and simple, like a lot of things we might do in this, we have a status for new. If it's past the validation, there's no issues with the JSON itself. If it's been processed into a sales order, then it will go to the process status. And if the sales order has been successfully released, it'll go into release status. And then if we successfully tell the warehouse that it's been fulfilled, if we send the email, it will be sent, and so forth. So that's our baseline. And I'm going to kick off the first example here, our older methodology. And we're about to go look at the code, but it's worth running this code while we're at it. A quick aside, in case anyone's unfamiliar with the Performance Toolkit, the BC Performance Toolkit, if you are running Dockers, you do need to tell it to install the Performance Toolkit. I believe in sandboxes, it installs directly. You cannot run this in production environments. And if you're on-prem, you would also have to install it yourself. But the performance toolkit here allows you to define what code units you potentially would like to run, for how long you would like to run them, and how many and should they run at the same time. So to mimic a standard way we did in the nav days that a lot of people in BC still do is we have one code unit that is going to run in a job queue. It'll run through all the steps and then it will be done. And that's the baseline that a lot of people do development work. So we're going to run that just one session the old way. And I will kick that off. And we can see I'm going to get some info about it validating. While it does that, let's look at what the process does here. Anytime I'm writing code, I use a lot of Copilot to generally encourage my code completion and whatnot. So one of the things I will typically do in the beginning of a code unit is describe the overall process of what we're doing. With a nice little block comment up here. And we can see that we are going to grab some input from that web queue table. We're going to check if the customer exists by email address and country code. If they don't exist, we'll create it. And the same for ship to. If for that customer and address and postcode they already exist, great. If not, we'll create it. Once we've got our customer and ship to sorted, we'll do the sales order creation. We'll do the lines creation. After the lines are created, we'll check the stock. If there's existing stock, which then we define what does existing stock actually mean, great, then we don't have to do anything. Do we have some stock in another location? Okay, we'll do a transfer order or we'll do a purchase order if there's none, and then we'll do our release sales order. And if we come into our on-run trigger for our job queue code unit here, it does exactly those steps. And I generally encourage you to keep the main entry point of code units nice and easy to understand. Extra functions are free. It's good, solid design principle to have your procedures be almost self-documenting. So we can read that, and let me make that a little bigger and get that out of the way. We can see that we're going to validate our new web orders. We're going to process the validated orders. We'll emit those to third-party systems, and we'll send some notifications. So the validation, in our case, we've got some extra little logging stuff in here, but effectively what we would do is we would just do any of our validation steps. And in our process, where the real heavy lifting is, we are going to iterate through each of our orders. And each of the operational steps, the validate, the process, the emit, and the email, are all individual little code units. So validate, process, emit, and email. If we look at the process code unit, this one's a little bit chunky. There's a lot of stuff in here. Same general principle in that we have some notes about what is it doing. And if we look at our AL outline here on the left-hand side, we can see that processes are named in a pretty safe way. So we'll do a check to see if a customer exists for a given email country code. And if we find it, we'll return it. Great. If we don't find it, we'll create it. And so there's a routine in here to get the information from the JSON to create the customer. Now, the key thing about the code unit that we were looking at here is we're using a pattern in here for code unit.run. In talking with the Tech Days crowd, a fair number of people were unfamiliar with what happens if you call code unit.run and surround it with an if. When you do that, a code unit.run where you catch the if statement coming back, because it can return a Boolean. If we mouse over it, it'll tell you that it returns a Boolean. The compiler knows that if you're capturing that Boolean, what it actually does is it spins up a new transaction. And what happens is when this code unit runs, if there's an error message inside the code unit, this will return false, but the error won't be logged anywhere. And the write transaction, all the writing to tables, creating customers, creating ship tos, creating headers, all of those things get rolled back, just like as if a user hit cancel if something errors in this process. It's then our responsibility that if it doesn't run successfully, to get the error text out of the engine and say, what do we want to do with this? And in my case, I'm logging an error message to the web queue, our transactions, so the user can see what went wrong. And I've also got a little logging system that will log this message as an error. The gotcha to that, to include this in the recording, is if you are doing a code unit.run, you absolutely cannot have any write transactions or locks on tables. So you do need to do a commit. If you do not do this, you will get an error message about code units cannot be called with .run. And honestly, the message is a little bit confusing. So in our process, we do each of those main 4 steps, and we're doing those through the normal operation, the sequence of things. So if we have 500 orders in the order queue, it's going to have to validate all 500 before it begins to process all of the orders into sales orders. And then it's going to have to finish creating all of the sales orders. And when it's done creating all the sales orders and customers and ship tos and purchase orders and transfer orders, when it's done creating all of those things, at that point, it begins to tell the warehouse system. And when we finally get through the process of telling the warehouse system about all these things, then we'll begin to let the end user know about the emails. Now, this was how our business process worked for our product, for our customer. And what they were finding is in those scenarios where there were 3,000 orders coming in every hour, that's a lot. We honestly were surprised at Business Central keeping up with some of the things that it was. But the problem is that it would need to get through all 3,000 of these validation steps and process steps before the third-party logistics would get those orders. And what we were discovering is that throughout the day, there were several times where the warehouse team was prepared for very, very busy day. And they would have to wait for half an hour because the job queue was just processing and processing. So the website was drowning in orders and the warehouse team was sitting twiddling their thumbs waiting for the next batch of orders to come in and then frantically trying to get through all of them. Not the best of situations for our customer to be in. So now we can see in the time that I was kind of chatting about that, it ran very quickly. It's only 2 or 3 minutes. We can see that we brought in those 500 orders. It created 500 sales orders. We had a whole bunch of transfers that had to happen between different locations to fulfill that demand. We needed to create some additional purchase orders around that. And all of them naturally converted successfully to web orders. We wouldn't have deadlocking. It was doing one operation at a time. No big deal. So that's not bad. And if we look at a visualization of how that process went, let's open up a little visualization to help us along here. Grab this mermaid here. We can see that in the process of things, pretty understandably, the way that this worked was that, sorry, my panning wasn't working. It went through a validation sequence first, and then it spent a very long time doing all these processing steps, and then finally began to do the fulfilling and the emailing. Okay, well, that's not bad. It's okay, but all systems have a limit, and as I discussed, our client very much hit that limit. So we're going to reset this environment, clean things back up, and we're going to do things a little bit of a different way. Before we move on to that, as I said, the biggest problem in this big standard loop of forever, we're just going to take this whole queue and we're going to do everything. All the orders had to get through each of those stages to move them to the next stage, or worse. We were having problems where the processing was taking so long that the job queue was timing out. And so things would get stranded partway along. They'd get picked up eventually, but that's a problem. So our version 2 strategy, parallel operators. Everyone I talked to said you can run multiple job queues, but it's going to lock the tables. And how do you know that the same order won't get processed twice? Because absolutely, you do not want to be in a situation where someone purchases things on your web shop and then creates a sales order in your system multiple times and you ship multiple times. Fixing that is very embarrassing. So how can we do that? And how can we not wait for things to get to our third-party logistics company while we're working on that processing step? So the key of our second version, our second iteration, is we're going to focus on batch claiming which operations that we're going to do. We're going to do small batches, one little bit at a time. And a key thing is that we have to do these as very atomic transactions. You saw that because I'm using that code unit.run, I have to do commits. Every time I'm doing that commit call, because that transaction is done and it's written, when I call that commit, it's also releasing all of the locks on all the tables. So the next job queue in line is going to be able to write to that table almost right away. So let's take a look at our scenario here. We now are nice and reset back to 0. And what we're going to do is we're going to switch to our second mode, our lovely little demo mode here. And what this is going to do a little bit differently, and I'm going to walk us through the process in a little bit of a different order here, is we are going to look at a setup table and define how many operations to do each time we try to do some operations. In my case, the operation is a validation operation, a process operation, an emit operation, or an email operation. Okay, so if the job queue only finds 50 orders to work on, well, it'll do 50 validates and then maybe 50 process and stop. So we're going to give it a limit, and we're also going to do some interesting bits around claiming operations. One of the ideas that I had gotten from peers in the industry about how to solve this problem is we could, and maybe some of you have already done this experience, in our web orders, we could update the order to say it's in process. Maybe we add a new status here that we bump it up to when something's working on it. The problem with that is that we're now adding a write transaction for every single one that we want to bump to in progress. So the concern here was we wanted to minimize how much we were writing to tables and locking the database. But you'll notice some of you are pretty sharp-eyed, and you'll probably have noticed that my message ID is kind of the only primary key I have here. This reflects our real world scenario where we had a table that was with a GUID primary key, and it was also composed primary key with a status. This meant we couldn't say entries 1 through 100, you work on them, you work on 101 through 200. We couldn't batch it up by number because we'd get a new GUID all the time that would be somewhere else in the sort order. So this operation method that I'm about to show you was also to address the idea of running multiple at a time. So when we're going to begin our operations, the very first thing that the operators are going to do is we're going to locate which entries we want to work on. And if we look at our process here, we are going to locate which ones are in the new status, validation, released, fulfilled. If we look at our locate new entries process, we are going to look through the queue for all of the new status orders that are waiting to be handled from the new status. And we're going to a couple times look at the beginning to go, do we have any more operational capacity left for this run? I use the metaphor all the time of our truck is getting loaded and we decided that our truck can hold 100 boxes. As soon as we hit that 100 boxes, close it, ship it, get it on to the next truck. So when we start looping through the operations, we'll also check inside the loop to go, is this over the limit? And once we have found an entry that we're ready to work with, we'll add this. And this is a list of GUIDs in my case, because the web order ID, that GUID, is my primary key. So, okay, nice and easy. I'm going to do a list of GUIDs of these are all the entries I'm going to work on for my new entries. And I'll do the same process for each of the other statuses, validated, release, fulfilled, however many we can get through until we hit our operations limit. In my case, I've got mine configured to, I think, 100 at a time. Once we've located all of these, we've now got a list of GUIDs for each of the status types. We haven't written to the database at all, so we're still completely in the clear on there cannot be any deadlocking at this point. We're just reading information. Now, once we've built that list, we can begin the process of executing each of those operations. And we can very much simply, because list entries allow you to do a for each loop in AL, we can say for each one, we will go get from the queue and we'll run that same exact business logic. The business logic doesn't need to change. There wasn't anything wrong with it. We're just going to say, okay, for this little list of entries, we're going to do this one at a time for each one of those orders. And then that's it. We just do the same for each of those operations. Because begin and after we're committing, we're locking for the very split second that we need to do this business operation, and then we're releasing the lock almost immediately. This makes it very, very easy. That's how we handled the process of the operator choosing which operations to work on. But the next key step was, how do we make them not step on each other? If the order is already being processed by one of the other operators, how are we going to handle that? So we have this lovely little procedure between locating all the entries and running the operation called emit claimed operations to team. And what this does is it takes our list of GUIDs here, and for each one of those, we build a JSON object with our mapping of the new operation entries, the validation entries, the release entries, the fulfill entries, and we are going to write that to a little table that we created called my operator control here. And what this is going to do is when it's time for this operator to say, here are the 100 that are going on this truck, they only have to write that JSON once to a control table. And that just gets plopped into this JSON claims blob. When the next operator starts to begin to run and it's going to do its process to locate all the entries, if we take a look here, the first thing it does is it looks to see what are all the claimed entries by the other members on the team. It will go through the operator control, and based on that JSON, it's going to build a list of all those different operations that are taken by somebody else. They're already on a truck somewhere. Someone's already packing them up. It's ready to go. And so we then end up with these lovely little list of GUIDs of what's already in process. So the new entries are already claimed by other operations on the other teams. And then in the locate entries process, when we're doing our location process, we can do a very simple these claimed entries list that it's, whether it's 2 other guys are working on this or 30, doesn't matter. We have a list of all the ones that are in operation. If that list contains this message ID already, then someone's already working on it. I'll skip it. If they're not already working on it, I'll add it to the list where we are working on, and we'll go ahead and drop those in the queue. So let's see that in operation, because I think that'll help a whole bunch. So we're going to want to have 2 instances of Business Central here so we can see as they operate. So in our performance toolkit, this time we're going to once again run for 3 minutes, but now we're running our second mode operator. Our second mode operator, we are going to run 5 at the same time in the background. And if we want to, we can even look at the control table for the operations here. And I've got some set up so that way we can see it nice and easy, and we'll be able to keep an eye on what they're claiming as we go. So let's start this up. And if we look at our operational role center, we can see that already in just the time it took me to reach to my keyboard and refresh, 500 orders have transferred all the way over to validated already, and we're already starting to get some master data. If we go real quick and look at the control table, we can come to see that this second operator here, these are all the claims it's working on that are the validation entries. It's only working on validation, none of the release or fulfilled, and same. Most of them are going to be spending most of the time working on that processing step. So we can see the claim data very quickly and simply, and we're already about halfway through all of the orders. Those validate in very short order. This could absolutely be tuned to run as many as we needed. We just recently, that same customer that we had to build this design for had a sale week for summer. We tuned this up to about 20 in operation. And this is a good time to also make mention of, I did get asked the question about the licensing implications of this. And if we look over here on Learn, in our operation limits, how many of these can you run? And this is defined based on the number of licensed users in a environment. So for example, we can do 5 per user, per licensed user. And I did double check with Microsoft about this, that is perfectly fine to do it this way. There's no downside to this. They agree this is a good use case for being able to do more capacity. And the nice thing is that if you have a very busy week like our customer did, and your job queues are really churning on the environment, they're going to see that performance demand requirement and scale up to make coverage of that. We can see now that we've already got 500 orders all processed, and we're starting to get the emails out the door, and we're done. And we have had 0 deadlock issues. There have been no problems whatsoever. Now, what that looks like, to explain it to a customer or a project manager, comparing it to what we were looking at before, we can see that each of these operators did a tiny little bit of the validation cycle, and they split it up between them. So by the time we got down to the 4th and 5th agent, all of the validation tasks had already been completed by the other agents. So these operators were able to jump straight into the heavier processing task. And we can see, if we look at the overall, that in my scenario, where it's just dummy data, we're just doing simple calls and all that sort of thing, the overall time isn't much shorter, but the time it took us to get to the point where it was starting to go through to the operational warehouse was much shorter than it was before, a 20% reduction when it's not real world scenario. In our real world scenario, the overall speed increase that we were able to prove out and test out with these tools was anywhere from 30% to 90% faster on an operational database. And we could scale up and down how many operators we were using at the same time. So The lovely thing about all that was pretty good. We did also get the question of, well, what if the job queues are running idle? We set them to run every 5 minutes and there's still a bunch of stuff in the queue. Or what if we're under heavy demand and it's taking them 10 minutes and some of those things feel like they're getting stuck? So we introduced one more last little piece, and I'll see if I can cover this in the 10 minutes. It's just a little tiny adjustment to the parallel thinking. We also added a small amount of logic to the control table where we said, let's use dynamic scaling. And we put a target operation on each of the operators that would be running and gave it a nice minimum maximum situation. So that way we had safety guardrails on it. And in our operations, instead of looking at a setup table for how many operations we should run, we pull this from the control record. When we're all done running the number of operations, if we're going to turn on that dynamic scaling, what we can do is we can say, okay, we've got it configured to run 100 operations, but in the run every 5 minutes, it finished way before 5 minutes was done. Maybe next time we could instead do 150 or 200 operations. So what this dynamic scaling logic does is it looks at the runtime that the job queue would be configured for, and it says, you know what? If the adjusted runtime is less than the time it took, then we'll increase the number of operations by 10%. And if it didn't get the job done in time, we'll decrease the number of operations by 10%. And then, of course, some good safety railing type things to make sure it doesn't go over the minimum maximum. So I know I went over that one a little bit quick, but I want to make sure there's time for questions. In the way that ends up looking in our control table is simply that we would see that as the system is running, if the system is running fast and there's a lot of demand on the system to run lots and lots of data, these target operations will go up. And if the system is running slow, the target operations goes down. So nice and easy there. Let's go ahead and reset the demo data, run that, and we'll see the dynamic scaling in progress. This can be used for a lot of different things. Anything that runs in the job queue that you can think of a way to kind of divide and conquer a little bit. I talked with a couple of people after the conference about this. They were looking at, routines where they do item adjustments, they do costing, anything where you can chunk up the operations, you can potentially use this pattern. I did also want to highlight while it's doing that reset that if you want to, over on the GitHub, for me, we've got the repository where all of this code is. So I know I'm going a little bit quick through some things, but if you wanted to see what is the logic, all of the stuff that we just went through is in here. And our different 3 modes of operation, the old way, the new way, and the dynamic scaling way are all broken out. And I've got lots of comments in here to explain what's in here, as well as a README file to explain the process flow and some of the things that you need to know about this. So that code is available for you to try out for yourself, so that way you can see how it works. Maybe come up with some of your own designs for this. So with our nicely reset situation here, we've got 500 orders in the queue. We go off to our dynamic scaling mode, and once again, we'll run with 5 of these in the job. And we'll kick that off. And while that runs in the background, which won't take very long, it's already half done with that first step, let's talk the last little bits. Critical considerations, like I said, tiny atomic transactions, meaning it should be trying to do a little bit at a time so that you can break things up. And it's important that we break them up in smart places. Commits are dangerous in the AL world. For example, if I created the sales header and then called commit after the sales header was created and something went wrong with creating the lines, I would be stuck with an empty header. So be very thoughtful about where you have the commits in your environment. It's essential to have good error handling, so that way the job queues can continue to run. If your data is bad, something comes in from a web shop, for example, and it's bad data, all of those operators could potentially get stuck if there's some sort of situation that your error handling doesn't take care of. And it might also be valuable to have retry scenarios. I didn't do that in this environment. When we look at the web orders, for example, in our customer environment, we may retry an order 2 or 3 times if there's some transient issues or whatever. So you might want to consider some retry logic on those as well. Let's see. Okie dokie. And let's see how we're doing on that. We're almost done creating all the sales orders, and we can do the last little reveal of how the operators are behaving. If we look at the operators now, we can see that they've been scaling up. So now this operator, for example, is going to try to do 47 at a time, not 20 at a time. So if they are running faster than they expect to take, they finish their work early, let's ask them not to just take a break at the end of their shift. Let's ask them to come back and take a little more work next time. And we can see that as things really cranked up, it eventually started getting to the point where it could say, look, I can do way more than 20. I can do 100 at a time. So there's a lot of scaling that you can introduce to that. And if we look at the final results on that, it gets a little bit big, but the results are very similar because the logic doesn't change a whole lot. But where this makes a big difference is if you set the jobs to run every 10 minutes or every 20 minutes, and they sit idle for 5 minutes, this is a way of reducing that idle time. And the more you can reduce the idle time, the more it looks to Microsoft, they can see the demand in the environment as higher. That means that your clients who are on cloud in a production environment, Microsoft will scale their environment to be higher because you're using much more of the resources available and it's more consistently demanding those resources. So you'll start to get better performance out of Business Central in the cloud just by having it dynamically make sure it's always busy. I did also make mention at the beginning that this was a Copilot free talk. I just wanted to share a little surprise for the people who didn't realize this. A small thing, and I'm going to be doing some more online sessions about this. Every little bit of code in this demonstration app, I actually did not write any of it. I challenged myself for Tech Days to only instruct my Copilot using the instructions in my README and everything like that to create this solution for me step by step. So I'm going to be doing some more online events that you can watch on YouTube and that sort of stuff that explain some of these Copilot sort of things because it can be very, very helpful. And I had a lot of fun with that. I'll share the deck with Masange to share out to people as well, to give some of the examples of some of the types of prompts that I was giving to Copilot to produce this code. And I did get the question from people, how was I doing the flowcharts to demonstrate their performance and everything? And that was coming from a markdown tool called Mermaid. This is a tool that allows you to do all sorts of different diagrams. So for example, if we clear this out of here, and we can show all sorts of different flows. We can do different sequence diagrams and things like that. In my case, I was using the Gantt chart to demonstrate some processes. And what I was doing is in the extension, and again, this is in the GitHub repo, so you can grab it. I had a code unit generator that read from my log and actually generated the mermaid text to demonstrate what the amount of processing times were going on. So if you needed a non-telemetry way to visualize how long something is taking, you could potentially do something like this, where you just click a button and it creates a text that you can copy and paste over into a mermaid tool and be able to demonstrate that. All right. I think that kept me down to the target time I was told, which is that I should leave about 5 to 10 minutes for Q&A. So I guess any questions so far?
One in the chat, you can follow.
Yeah, absolutely. Lots of links in the chat. Let's see. You have, and the question in the chat, just to share it with the group, is that they've got 10 job queues in BC14 and that it's creating deadlocks very quickly. That is absolutely the sort of thing that we would run into a lot with job queues, especially if you're writing to the same tables. These are some patterns that you can bring in to help with that. And the way that you can look at is those 10 job queues that you have, it depends on what they're doing and what tables they're writing to. So what you'll need to look at is, I would suggest doing a process diagram that looks at the earliest time each of those processes begins to write, and the last time that they begin to write, that you can break up into separate steps, that it would be okay. Like if you got down to here and you got an error message, would it be okay if all this stuff up here is written to the database? If it is, that means you can commit halfway through, and now you've released the locks halfway through. Are there any parts of those long-running processes that you can break up into smaller processes to run with commits between them? The more you do that, the more you create opportunities where someone can go, and now it's my turn, and they can jump in and write. And what causes the deadlocking situations is when locks either go on for too long, or a write transaction begins here in one process and it's going to go right to a second table, and a separate process is writing to that same second table, and now it's waiting for the first table to be available. So you kind of have a collision where they're each waiting on each other. So those are the two different scenarios you can run into where locking is going to happen the most. So if you can sequence how you write things, that can make a big difference. An advanced technique for you, if you want to research into it, some of the things that I've done in the past to help reduce locking is write all of the things that we're going to write to the database to temporary tables first, to compose all the data that we're going to write, and then do all of the writing and one big step at the end. And that way, all of the thinking, the processing, the computing, the finding information, I do all of those things at the beginning and all the writing at the end. That can really help with deadlocking issues as well. Alrighty. Do we have any other questions that, if people are feeling
any other
microphone
question?
shy?
You can unmute and ask. If Fred, are you okay with that? Thank you, Jeremy, for the presentation as we wait for other questions. So Fred is satisfied? Okay.
Sure. Absolutely. And one of the things that I would recommend, if you are experimenting at all with Copilot, because when it's useful, I will use it. And in this case, it's pretty useful. One of the other things that you can really get out of it, let me go back to screen sharing for a sec, because this is actually pretty nice. I teach a lot of my juniors these days to do this sort of thing as well. In our Operation 1 here, this is a very, there's a lot of stuff happening. And each of these code units that we're calling does a bunch of stuff. So what I did is I actually did a chat, and this is the only prompt I gave it. This code unit does a lot of things. Can you do a mermaid flowchart of the top level process and then a separate sequence diagram for each sub step? And what the Copilot for me did was it actually read not only this code unit, but it went and read through each of those processing code units. And it went, okay, let me check what the mermaid documentation is. And I'm reading all that stuff. And it worked along for a little bit. And then it finally, in the end, gave me a flowchart file. And if we take a look at the preview of that here in Visual Studio Code, it gave me this diagram that said, here's the top level process so that we're doing these things. And then for each of the steps, what are we doing? It's going to go to the web queue. It's going to do some web queue stuff. It's going to do logging. And for each order that we find, it'll commit, it'll run this process. If validation fails, it'll do these things. If it succeeds, it does these things. So one of the things that you can do to help identify locking and writing issues is you could ask Copilot to run through and identify in this kind of sequence style, when does locking begin and when does the lock get released? And you might be able to identify some places where you can encourage the locking to let go. If you encourage, the more you let go of locks during the writing process, the less deadlocks you have, and also the faster performance.
Okay. Okay, that's creative. Like one sentence prompt, but getting you a lot of detail and information. Ronald has a question. Ronald, you can unmute and speak. Sure. Oh, you are testing the raise hand.
Oh, thank you, Francis.
Okay.
Thank you. I think one of my question is that about the deadlocks in the JEP queue, and I think Fred Mbaye was asking that question. I think how do we try to avoid when we are using job queues? Let's say, for example, we are trying to write on the ledger entry GL entry, because at times I find that table is being locked almost most of the time when we are running job queues. Let's say even I have 2 job queues and that GL ledger entry is being locked each and every time.
Yeah. I've definitely run into that as well. For example, I worked with one customer in North America where they were using JobQ to post general journals that were imports from some of their companies or some of their locations. And some of the journals that they were importing were 100,000 lines. What was happening by using the standard posting process, they would say, just post the batch in a job queue. We're using background posting, go. I don't know where the kind of like general guideline has come from, but anytime you start getting to 10 to 50,000 lines, things get a little slow. And then over 50,000 lines, things can get very slow. So what we did for their scenario is we ended up adjusting the import routine to write, those big 100,000 batch lines. We broke them up by ranges of the document numbers so that they were still in balance. And in those scenarios, we broke those up to multiple batches. And we found that if we broke 100,000 line up into, say, 100 batches of 1,000, if posting the 100,000 lines took 10 hours, we were finding that each of the 1,000 line batches was only taking about 5 to 10 minutes. And so in total, it ended up taking 20 to 30 minutes instead, because we were able to break them into those smaller batches. So that would be one of the things that I would encourage also looking at, is when you are trying to figure out, big locking problems, is how can I make the operation take less time from beginning to end, even if I have to run it more times. That'll generally get you a lot of good performance gains, because under the hood, when Business Central is talking to SQL, all of those transactions that haven't been committed to the database yet are going to effectively kind of like a transaction scratch pad. Because if on line 90,000 of that 100,000, something goes wrong, what ends up happening is it has to be able to roll back all those 90,000. Those temporary transactions, the bigger that list gets, the slower the process goes. You probably have seen this a little bit too if you've been using like the rapid start config package imports. Once you go over about 10, 50,000 lines, the configuration packages go very, very slow. And it's that same idea. There's a big pile of working stuff. I like to tell people to think of it as if you give a clerk in an office, 20 forms to fill out, he'll work on those 20 forms. But if you show up with a pallet of boxes and just slam all the boxes on his desk, he's not going to be very quick about it. He's going to work a lot slower. I did see also a couple of last little questions in the chat as well. The operator process, could that be applied to the adjust cost report that locks the item ledger entry table? I would say hang on trying to come up with new strategies for that just yet. I've seen some of the performance gains in 26 and planned for 27 around the adjust costing routines to make them run faster from the Microsoft team. If those don't help, I will encourage them to come up with a multi-process adjust cost report that we would be able to run, because a lot of people have that problem. Absolutely. And there was also a question on an automatic job queue restarter for the transient errors issue. I encourage everyone who is using job queue to always set the number of retries and the time between retries. Don't go too crazy. So like, for example, if you set the number of times to retry a job queue to 50 or something huge like that, be aware that the time between retries that you set might only be 1 minute at first. But what Business Central does is the number of retries, it actually exponentially grows that amount of time between retries. So at about 20 retry attempts that are failed in a row, you might have started 10 seconds between run, and now it's up to 18 hours between attempted runs. In relation to that, I usually set the number of retries to about 5 or 10 and keep it kind of small. But there is now a telemetry event for when the job queue fails and is not going to retry anymore. And what we do for our clients who live on job queues is we have a logic app in their environment that watches for that telemetry event and sends an email to the client and a Teams notification to us to let us know that a job queue just failed and it's no longer going to try to retry. So everyone gets a heads up about it. We do have an automatic restarter, but typically if something fails more than 5 times in a row, there's usually a problem that has to be resolved in a configuration that just trying again is not going to help. So typically a lot of our retries are in the 3 to 5 range.
Okay, I think sounds good. Madison, do you have anything for closing? Yeah, already at the end.
No, just if you guys wanted to sign up for the East Africa Regional, I sent the link in the chat and would encourage you guys to sign up. And yeah, just
It's
excited to
sold
see you
out.
guys soon.
Nobody can sign up.
Oh, I totally forgot it was sold out. If you're looking to get a last minute registration, just send me a Teams message and I can get you added onto the wait list.
Okay, okay, guys, you have had it. If you need to go, you need a last minute registration, just send Madison. Can you share your email so that they can get you on Teams for that also?
Yes,
Okay.
I'll send it in the chat right now. Thank you, Jeremy, so much. Great presentation.
Absolutely. I know it was quick and fast, but hopefully everyone can kind of spend some time with the code in the repo and get familiar with some of the strategies and think about what they can do with that.
Okay, sounds good. Have a great
Alright.
one, everyone.
Thanks,
Bye-bye.
everybody. Have a good rest of your week. Bye.